Welcome to the second in our series of webinars about Vulcan 10. Following on from the introductory session last month, we now delve into more detail about some of the new functionality. Today I introduce Eduardo Coloma from Maptek Perth. Eduardo, you travel the world helping customers with their mine planning. What are some of the important problems that engineers are solving at present?
Hi Steve. Hi everyone. Well, as you probably know, 2015 will go down in the history books as one of the worst years on record for mining companies, hit by record low commodity prices that forced them to think differently. In this new environment, the miners are forced to improve every part of the process. Mine planning is no exception. Today, users need the ability to run as many scenarios as possible in order to explore different alternatives to discover the hidden value. Vulcan 10 contains several new tools that can help speed up your processes. During this webinar, we will focus on three main areas: pit optimization, how to create different pit design with the information generated by the pit optimization, and finally, how to transform this design into mining blocks. The goal of open pit optimization is to find the optimum ultimate pit so that the profit from mining the pit is maximized. Each block in a three-dimensional block model is assigned either a profit or a loss based on the revenue and cost associated with mining the block. Geological constraints are used to establish a slope requirement for each block. These are used to determine the block which must be removed prior to removal of any other given block. Maptek delivered Pit Optimizer with Vulcan 9.1. It replaced single element and multi-element modules. In addition, we added a cut-off rate optimizer module so the customer can get access to this new functionality straight away. One of the important elements delivered in Vulcan 9.1 was a new algorithm that allows users to get the same solution as with the Lerch and Grossman algorithm, but much faster. In some cases, up to 90% reduction in time has been noted. The ability to run multiple analyses with Pit Optimizer allows users to focus on the information rather than in trying to connect different applications. In addition, users have the ability to display the result in Envisage, create animation, and generate surfaces that represent each pit in an easy way. This chart shows the performance of the new push and relabel algorithm. In the x-axis, we have different block model size, from 200,000 blocks to nearly 4 million blocks. The results are represented in seconds as displayed on the y-axis. In this particular exercise, as soon as we add more blocks into the optimization, the user sees the benefits associated with the improvement. As I mentioned earlier, in some cases we can increase the speed of the process by up to 90%. Another important point is that the results with push and relabel are the same as the result using Lerch Grossman. As you can see in the lower graph, the correlation between the pit chart are the same.
So Eduardo, summing up the Pit Optimizer, we've improved the performance for faster turnaround of results and providing a better workflow for mine planners. But on the screen there, it's still producing blocky looking outcomes. Where do we go from here?
Well, you are absolutely right, and take the result from an optimization, essentially pit shell, and use the result to create some preliminary pit design, essentially toe and crest, but in an automatic way. So this preliminary design should consider at least obey butter and burn configuration, incorporate the majority of high grade presenting the optimization, obey minimum mining width constraint, and so on. In Vulcan 10, we added the automatic pit designer tool. This new option allows you to consider the majority of the points mentioned before, and the most important thing, you can get the result in a matter of seconds. In Vulcan, there are several different options that allow users to create pit design. This runs for a very user-dependent option like RAM, essentially bench by bench, to Rapid Pit Designer, which allows users to work in a semi-automatic way, multiple benches at once, but using a mid-bench approach, and up to Automatic Pit Designer, which is a fully automatic tool. You can model multiple benches at once, following a specific variable flagged on the block model. Automatic Pit Designer uses either pit number from a given block model or design data in the form of closed polygon to automatically project benches and offset an appropriate operating width to create high-level operational pit design. This means that users have full control over specifying different bench height, burn, butter angle, and/or slopes. multiple options are available to use. Users also have full control over operational parameters like minimum mining width, digability, snap phases, etc. One of the most important points is the ability to run one or multiple stages at the same time. The information can be exported in a layer or a triangulation to be used with the standard tool in Envisage. Automatic pit designer has delivered geometrical representation of the pit. Ongoing development will see us providing users with a more value-driven option. And the next stage of this project will be add functionality for ramps. This will be a big improvement, and our users will get the benefit soon. One of the important features is the ability to run multiple phases in one pass. An option allowing to snap to the previous pushback helps to reduce the difference between stages. In this slide, we can see 3 different pushbacks which are being generated automatically by reading the block model and taking into account geometrical constraints. The user interaction to produce this design is all provided through the panel. There is no user manipulation to create this polygon and triangulation.
So Eduardo, the automatic pit design provides much better visualization of potential pit models. It runs very quickly and allows dynamic control to the planner to change the parameters and see the impact of those changes. So how do we break this long-term design into smaller blocks for mine scheduling?
Well, after we create our pit design, the next step will be how to take one of these pit design and represent mining shapes in a bench. For instance, blast master, etc. Here is where the new option Interactive Block Planner coming into play to generate this polygon. This option is part of the Mine Modeler OpenCAD bundle, so if you're under maintenance, you will get access automatically to this new option. Interactive Block Planner allows users to specify all the information required for this process and generate mining blocks accordingly. This process is connected dynamically with the block model, so users can see the associated tons, grade, etc. Part of the process is the addition of the attribute in an automatic way to the polygon that has provided more information that can be shared across different levels of the organization. Lastly, to improve your workflow, it's called command list. It allows you to compile a workflow to connect various tools to streamline your tasks. Let's say that you have run a typical pit design process. The next question will be to find out how much material is inside this design. Command list sequences all of the many options and tools connected with your process. Hold that thought. At the end of the demo, I will show you how it works. So let's jump to Vulcan to show you the tools that I mentioned during this session. Let's start with Pit Optimizer. All right, so Pit Optimizer is on the block menu. You can get access to this particular option. It's based on a specification file that allows the user to reproduce every single run. It's connected directly with the block model. It's very easy to follow. Basically, following the tree, you can actually incorporate all the variables and all this the want to consider the optimization. An important functionality is the ability to, for every variable, you can define a fixed value, or you can read from a specific variable as well. One of the things that I want to point out here is that our Pit Optimizer is running with push and relabel. But if some user want to use large cross ticks box here, which allow to call that particular algorithm. Another important thing is all the variables can be created on the fly. So the user don't need to prepare the block model. This is created automatically. Another important point for the Pit Optimizer is how you can manage the subregion or the geotechnical information. Pit Optimizer provides all the options in order to model this in a better way. So you can pass the information using polygon, triangulation, and even reading for a specific variable. For every subregion, you can define an angle list, which essentially you can define the bearing and slope. Another important thing is regarding with the remaining factors. You can define a fixed step, or you can define the step that you want. But the important thing, the user has the ability to define where the preventive factor will be applied. So at the end of the process, you will see if your pit is more sensitive to the price or any of the other costs. After you run pit optimization, then you can pass to the analysis. This is pretty standard. You can get the best case, worst case, etc. You can run multiple cases at the same time. you can actually flag information back to the block model, especially the PD variable. You can generate multiple reports, and also you can generate multiple charts. All this information is exported to Excel. Another interesting thing is the visualization. Let's try to run something here. Let's say that our final bit is the number 18. So what we want to do is just to try to visualize this one in this new option. So the triangulation has been generated. We can come here. Screen. As you can see, it's a very nice triangulation, but again, it's just that we are actually trying to represent here. Another way to display the information is through the contour of the block model. So I got the same result here. Let me bring here and remove the triangulation for now. So as you can see, you can generate this contour at the moment, reading directly from the block model, but still, it's not what we want in order to represent our pit design. So this is where automatic pit designer comes into play, and the open pit automatic pit designer. Again, you are using a specification file, which allows to generate multiple scenarios. The option is pretty straightforward. You need to select the block model and then the pit variable. In this example, I got 18 different pictures. So let's say that we want to generate the final pit, which is the 18 in this case. Without necessary to define any other information here, I will show you later on, you can actually come here and run this particular exercise. So let's take a look now. As you can see, it's quite faster. So now we got the result on the screen. Let's take a look to the different elevation. There is a really nice option here, which is called section, which allows you to predefine this one, and then you can move forward in different elevation. So as you can see, automatic pit designer is following quite nicely all the results coming from the pit optimization. But obviously, there is more information here that we can actually want to share with you. Let's go back to the automatic pit designer. And let me show you a few more things. As I mentioned before, let's run in this one again, and let's take more attention to the result. We got this area here, which essentially is a corner. Maybe it's not operational at this stage, and this is when the automatic pit designer is quite interesting, because you can actually modify the parameters and then you can improve your design. So let's say, for instance, that we want to use a minimum radius of 35. As you can see, the result is updated automatically. Another example that we can take a look here maybe is in this area. As you can see here, this is the bottom bench, and probably we don't have enough space in order to work here. And maybe we had a rule that we don't have, we cannot mine less than 50 meters. So the user can specify that one, and obviously this will change a little bit the design. But the important thing now, you are taking in consideration this thing. You've got plenty of different options to play around this with automatic pit designer. You can actually play with different benches, so you can simulate single benches, multiple benches. You can use different body angles. You can read from the block model, supplying directly the body angle that you want, or maybe you can, maybe what you want to generate a relationship between one specific variable like subregion with different body angle, or even you can specify an angle sleeve. Same thing for the bear width and for the pit slope. But let's think that for now it's fine, and actually what I want to is save this information later on. So you can save this information here in a layer, and also you can provide a specific name for the triangulation. So let's save now this for now. Let me cancel here, and let me bring the triangulation. As you can see, the resolution of the triangulation is quite nice. Now, one of the interesting things, as I mentioned before, was the ability to run multiple pits or multiple phases at the same time. So let me show you how that works. So let's come back to the automatic pit designer. And now I got 18 different pit shells, and let's say that I really want to generate 3 different pushbacks. So we got a couple of options here, but let's say that we want to generate similar tonnages. So I will hit this button here, and that probably if I use the picture 1, 10, and 18, probably I will make similar tonnage. So if we keep all the parameters, then we can save straight away, and the system will generate the 3 different phases in one shot. So now we can see the layer on the screen, but more importantly, we can take a look to the triangulation as well. This information will be very useful for the next step, and imagine how much amount of job you can do with this new option. So let's say that we are quite happy with the results so far, but now I want to take one of these designs and actually move forward and trying to break down in different mining shapes. So let me show you another option. We got interactive block planner, which is under OpenPit, OpenCAD design. So you can get access to this option. It's connected directly with the block model. So we can select the specification file. We can take one of our pit design and use like a reference for our job. As you can see, you can visualize different benches at the same time with different graphical representation. Because we are connected with the block model, you can define as many gray items or variables you want in the report area. You can display the block model as well. So you can use here and select the variable that you want to display. The system is quite simple and dynamically, so you can incorporate more information if you want. Let's remove this one for now, just to be more clear in what I want to share with you. Then we move to the design. In the design area, we've got different options here. So let me explain a few of them and see how we can use this one. So the first option is how I can generate different mining shapes here. So the create option is essentially define the boundary and define the area that I want to calculate. Because we are connected with the block model, all the information is displayed on the screen straight away. You can actually see every single polygon. So let's try to do another example here. Let's create a couple. For instance, that one. And then let's say that we want to generate something like that. All right. Another feature is the ability to run. We can run one by one, that's fine. But what is really cool here is the ability to generate multiple cuts at the same time. So let's say that we want to generate 3 cuts of 200,000 tons in an automatic way. So again, we go back to the options, select the boundary, and then select the line. So, and then obviously we need to provide the direction. The system will try to find the different area of volume, 1,000 tons that we are looking for. In one shot, you will have 3 different things automatically. But to be honest, I did this one in purpose. I think this is wrong. And the idea behind this one is to show you a few more options that you can play around. How I can modify this block here, which doesn't make any sense. We've got a bunch of different options at the top that can be useful in this process. For instance, I want to merge this polygon with this one here. So I can use the merge option. And automatically it's merged. More importantly, all the attributes are recalculated because we are connected with the block model. Obviously here, doesn't make any sense that one, but we got an option to delete the polygon. And now we got the result again. And if someone wants to split again, just make a partition and you will have the result that you are looking for. This option allows to display all the report as well, dynamically. I didn't open because I don't have enough space now, but if you got a multiple monitor, this works quite nicely. So this is dynamically. You can see all the numbers coming through without any information can be exported to a CSV format. So that is Interactive Block Planner. Let me close for now. Remember that I mentioned the command list? Well, now it's time to talk about it. The command list is one of the options that is available under the workbench. So we got this option here, and you can get access to the customize option over here. So you need to select the command list, and I prepared a couple of them just for this webinar. But let's take a look at this one. I got a different process here running together, but I really like the automatic pit designer now. So I want to add this one in my workflow. So let's go to the envisage. Where is the open pit, automatic pit designer, and let's bring to my process here. You can also change the icon if you want. We are providing different icons, so you can select here and customize all the information that you want to do. That's it. So now, how I can get access to the command list? Well, there is a menu here which allows to display all the command lists. Let's try to run. So this is my process now. We've got pit optimizer, automatic pit designer, etc., etc. I don't want to run pit optimizer for obviously for time constraint, but let's go to automatic pit designer. The good thing about this one is you can skip the step, as you can see here, and then you can actually run one by one if you want to get, if you want to check the result for every option. So let's run in a single step now. Let's go for automatic pit designer. So let's bring the panel here. Let's say that we want to run our favorite pit, 18. Let's save it. That's fine. Let's say that the next step in my process is load the topo and the design. So let's run it. So let's bring the topo on the screen and let the design that I created now. Right, so now I got my information on the screen. The next step will be reserve solid, which essentially is to create the volume between the surface, but at the same time create the new topography as well. Again, all these options are part of the Vulcan at the moment. It's just we are connecting them. So we generate the volume. Right. And let's a specific color here. Right. So the next step will be remove some element. You can put the remove here in the process as well, but one of the interesting things that I want to show you is that you can actually work with the workflow itself without any problem. So let's remove the topo for now. There we are. And remove the design as well. And we got our pit designer. So if we take a look in detail, so what will be the next step for this exercise? Well, if I want to calculate number, I need to make sure that I need to check, and recheck the solid. And this one essentially, let's run it. And I'm checking here, just the important thing at the moment. And this solid, let's check it. So the solid is fine, so we are pretty much ready to go to calculate the reserve report. One of the nice reports is advanced grade tone curve. So let's say that we want to generate the cutoff rate curve for this one in a simple way. All the information will be exported to Excel, and the option is creating the graph for you. So now it's working, it's finished, and let's go here just to take a look to the results. The interesting thing here, this is Excel information, so actually you can modify, you can change the thing. If you're not happy with the title, you can remove it. You can apply all the things that you really want to apply. But again, the important thing here is that you are actually combining all the elements that you want to add in your particular process in a very streamlined produce different steps in a simple way. So, well, that's basically what I want to share with you today. I hope you enjoy, and I will pass to Steve now. Thanks.
Thanks, Eduardo. You've shown us a number of different improvements and very powerful new features for mine design and planning. These can be used standalone, as you showed through your demonstration, or at the end wrapped up into the new command list functionality that was introduced for the first time last month. For those of you who haven't downloaded Vulcan 10, it can be downloaded from users.maptek.com as per the slide on the screen. You'll need to have a current maintained Vulcan version for that. Then your login and password, you can request that, and you'll get access to that area to download that version. Now, once you've installed it, and if you need additional information, there are more Vulcan 10 webinars planned for next month and ensuing months. The next mine planning ones are later in May. We have the split pit solids and the stratigraphic upgrades talk by Peter Odens and Stephen Hoffler. Then we've got some geological talks on variogram analysis and new uniform conditionings, implicit modelling. And then in July we have the talk going from where Eduardo's left off with the interactive block model reporting into evolution for the short-term and long-term scheduling. So I recommend that you register early for those. We are getting quite a high demand for our webinars. There's a lot of interest in Vulcan 10. Now, Eduardo, we've got a couple of minutes left for some quick questions. Are the new mine planning options included in the current mine modeler licenses?
Well, that's the beauty of this one, Steve. Actually, the automatic pit designer and the interactive block planner are included in currently maintained mine modeler OpenCAD license. So if you are under maintenance, you are ready to go to use it.
And the performance of the automated pit designer, how about with a real block model, say 1 million blocks? How does it perform there?
Well, look, during the testing phase, we have the opportunity to involve a couple of customers to try this new option as part of our beta program. One of the customers has a really block model. If I remember correctly, were like more than 20 tell you that the performance of these two was really, really good. So there is no compromise at all.
Excellent. And a final question, one of our customers has asked, how about the automated pit designer and some ramp? What are the future development plans for this option?
Yeah, well, I totally agree. If we can simplify all our in a single, we can say, we want ramps. You know, let me tell you that we already made some progress adding ramps. Our development team is working hard in this one, but of course, we got different kind of pit. Some of the pit have more than one ramps. Another pit want to access to the bench. Another doesn't want to access, etc., etc. So there is a lot that remains to be done. Currently with this one, we are working in a specific user story and a small enhancement. This includes selecting which block to be mined based on a block selection panel, and obviously provide an option to generate or get access to this option to external programs. So the user can actually incorporate this one for scripting purposes as well. After the phase 2, we finally move in a more exciting bit, which is essentially the ability to use the economical block value as an input. In this way, you will be able to, let's say, optimize the whole as by moving the run around and optimize the design itself. But that is a long way off at the moment.
Thanks, Eduardo. And for those that are in Australia and want to have a chat with Eduardo, next week in Perth, from May 10th to 13th, we have a series of workshops with Vulcan 10, as shown on the slide there, various different capabilities, so we'll have interactive workshops. So those are in Perth, welcome to attend those. We will also be running similar functions in upper Maptek offices. So once again, Eduardo, thanks for sharing these mine planning scenarios and the new tools. Obviously, it's not possible to go into great depth on all the aspects, and this afternoon we just wanted to give you an overview. If you need any further information, please contact your Maptek office. Also, if you want to, as Eduardo said, we are working further on each of these options. If you want to contribute and have your say and be part of our development and beta testing program, again, contact your local Maptek office. If you're in Australia and you want to talk to us, the contact numbers are listed on the screen. If you're interested in watching this presentation again, you'll receive an automated email notification when that recording is available, and that will be available on maptek.com, and you can share that with your colleagues who weren't able to see this webinar today. Thank you again for listening, and bye for now.